The last of the special cases we're going to cover today are the sum and difference of cubes. And again, these are special binomials that are always factored into a product of a binomial and a trinomial following a very specific pattern. Now, unlike with the difference of squares, difference of cubes also has the option for sum of cubes, so we could do either one, plus or the minus. Consider what values are perfect cubes. Well, 1 cubed is still 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Now these will probably get you through most of the sum and difference of cubes problems by recognizing these values. Be very careful because 4 cubed is also the same as 8 squared. So 64 counts as both a perfect cube and a perfect square. When we consider variables, x to the first cubed is x to the third, x squared cubed is x to the sixth, x to the third cubed is x to the ninth, and so this pattern follows with any exponent that is divisible by 3. And again, be careful because x squared and x to the sixth are also divisible by 2, making them perfect squares. So we want to pay attention. Does it fall under difference of squares or difference of cubes? So it follows a very specific pattern. And here's how the pattern works. We take the cube of two quantities. We get these values a and b. And we take the cube root. And so those values a and b make up the binomial. And the sign inside the binomial is always going to match the sign given in the sum or difference of cubes. And then from there, we can actually just focus on the values a and b to build our trinomial. Now with the trinomial, the first term is always the a quantity squared, the last term is always the b quantity squared, and the middle term is the product of the two. And then the signs are always going to be opposite for the second sign, and then the last sign is always plus. So let's take a look at a couple quick examples. So here we've got two cubed quantities, x and 2, and that's going to make up our binomial, and we're going to match the sign with the sum of cubes. Once we have our binomial, we don't really even need to look at this anymore. We don't really need it. So our first term is always going to be a squared, which is our first term, in this case, x squared. The second term is going to be a times b, so the product of the two, 2x. And the last term is always going to be b squared, which is our second term squared, which is 4. The last thing we have to do is fill in the signs. The first sign is always opposite, the last one's always plus. And there we have it factored. Very, very rarely will you be able to factor this any further, except in maybe some fringe case where there's a GCF or something that we missed that we could have factored in the beginning. Same thing here. We have cubed quantities, p and 3q. So those will form our binomial. We keep the sign that's in the original. Now again, I don't need to look at this anymore. It's not of any use to me. And so now we can use our binomial to build the trinomial. Again, it's going to be the first quantity squared, p squared, the product of the two, 3pq, and the b quantity squared. Now, keep in mind, 3q squared, both the 3 and the q get squared, giving us 9q squared. First sign is opposite, second is plus. Here we have a difference of cubes. Two cubed quantities, y and 4. We match the sign in the original factor, or in the original polynomial. Then we can go ahead and build the trinomial. First quantity squared, the product of the two, the second quantity squared. The first sign always is opposite, the last sign is always plus. So when we're dealing with sum and difference of cubes, the options for the operation signs are either going to be plus, or minus, plus, plus. Those are the only two that we're going to have. So if you memorize those two patterns, it's pretty easy to remember where it's going to go. When we look at D, 125 is a quantity cubed, but q squared isn't. But we do have a GCF of q squared, so we can resolve that issue pretty quickly. 125 minus n cubed. and then we have a difference of cubes. So we have our GCF going along for the ride. 125 is 5 cubed, and n is n to the third cubed. Then we can go ahead and build our binomial. The first term squared, the product of the two, and the second term squared. Since we started with minus, we're going to end with plus plus. And there is our sum and difference of cubes. These special cases are pretty easy to factor once you've got the patterns memorized down. The more you practice, the easier it's going to get.